Okay, so we start marking at 5a. Right, quickly have a look. All we had to do there is multiply ends to get rid of that bracket. And then from there, unknowns to the left, normal numbers to the right. And then you would get x is 0. Right, any questions? Can I skip? Right, hands up, we're still copying? Good. Okay, there's B and C. So at B, because I had the fractions where my denominator is 6 and 2, the lowest common denominator would then be 6. So that's why I'm saying I multiply every single term with 6. Okay. Do you guys understand this or not? Huh? Okay. And then at C, over here my denominators were 4, 2, and 8. And then over here it's actually over 1. Now, so between those denominators, the lowest common denominator would be 8. So that is why this first one, if I multiply with 2 here, it means I have to multiply with 2 there. And that's how I get this part. Okay. Then in the next one, I am going to multiply with 4. So if I multiply with 4 at the bottom, I also have to multiply with 4 at the top. And that's how I get the 4x. Okay, then after the equal sign, my denominator is already 8. So you'll see that I just have what was at the top. And then the last one, there we said my denominator is actually 1. So I had to multiply with 8, both at the top and the bottom. And that is how I get this 8. Okay, so is everyone fine up until there? Okay, now what I have to do from there is just multiply in. So it becomes 2x plus 6. After that, I simplified a bit. I said 2x minus 4x gave me this minus 2x. And on the right-hand side, I said that the 2 minus 8 gave me the minus 6. Then from there, I took unknowns to the left, normal numbers to the right, to get the minus 3x is equal to minus 12. And now I've got to get rid of the coefficient. So I divide both sides by negative 3. And that's how I get x is a positive 4. Yeah. This one. Okay, so basically we said I'm going to multiply with 6. Do you understand that part? Okay, so if I were to multiply with 6, it means I'm making my denominator 6. No. Okay, so technically over here I had 2 times 3, so I do it at the top as well. And that's where the 15 comes from. Okay. Okay, any other questions? Are you guys fine? Can I skip? Okay, D, last one. Now, what I want you guys to see is this 3/4 times 3x minus 5 is the same as 3 times the 3x minus 5 over 4. Can you see here I've got my 3/4? No? Okay, I just wrote it like that so I can easily see what my denominators are and what I should multiply with. Same here, there's actually a 1 in front. So this 1 over the 2 is my half times that bracket. Okay, now I can see that my denominators is 4 and 4 and 2. So I decide that my lowest common denominator would be 4, which means that this top part, I can let it stay 3 times 3x minus 5. And then this was already over 4, so it stays minus 9. But this last one, I had to make that times 2. So that's why at the top, I also have to times 2. So that is where this bracket of 2 times 2x plus 4 comes from. Okay. You had a question? You fine? Okay, then from here, it was multiplying in. So 3 times 3x gave me 9x. And 3 times minus 5 gave me minus 15. Then 2 times 2x gave me 4x. And 2 times 4 gave me 8. Okay, so now that I've gotten rid of all the brackets, now I want unknowns to the left, normal numbers to the right. People just open those windows, please. Dis nou die graad 10 wat dit weer toegemaak het. Ons moet 'n bietjie ventilasie ook hê. Otherwise, I'm going to switch this thing off. Okay. So, if I take this 4x over, it will become minus 4x. And 9x minus 4x gave me this 5x. Okay. Then, minus 15 minus 9 gave me minus 24. And if I take that over, it becomes plus 24. So 8 plus 24 gave me that 32. And now I've got to get rid of this coefficient of 5. So I divide each side by 5. So x will be 32 over 5. And that's also the simplest form. It couldn't go any smaller than that. Okay. You good? Any questions? Yeah. Yeah? Yeah, cool. Anyone else still copying, yeah? Okay, then you guys can copy that so long.
I just have to sit a little bit on. But so I always three.
Okay, yeah.
Is it okay that I still left this side in brackets because of the whole?
But wait. And the next one is 15 minus 9. And then 4. Oh, okay. Hmm. Yeah, that's fine. Perfect.
Oh, okay.
Yep.
I got my answer right over here. But the
At B.
yes, ma'am. But I didn't work it out like ma'am.
Okay, plus go. Minus H. And you have to say this fine. Then you say that cancels out, so it's only this. Then that's 2.5 minus 2 will give me a half. And then times 6. Nou, wat's fout hiermee? It's perfect. Ja, vee daai kruisie uit. Hy's reg. Okay. Right. Any other questions, people? Can we carry on? Okay, so now we've got to do equations with exponents. So please keep in mind all those rules that we did about exponents way back. When? Term 2? Term 1? No? Okay, right. So, if I give you 2 to the power of x is equal to 8, I now need to solve x. So the first step that you do is get base the same. Okay, get bases the same. So I'm going to say 2 to the power of x is equal to 2 to the power of 3. So instead of 8, I say 2 to the power of 3. How did I know 2? Because I want my base to be the same as what I had on the left-hand side. No. No, you could have said cube root of, but you wouldn't have known it's cube root. So sometimes it's a bit of trial and error. The more you do it, the easier you're going to see it. But you know base must be 2. So you can see 2 to the power of 1 will give me 2. So it's not that. 2 to the power of 2 is 4. So 2 to the power of 3 gives me 8. Okay. Yes. So not divide. Now you can see, remember we've got an equal sign. Base is the same on both sides, which means that I can now only go look at exponents. Okay? And because that equation is telling me that this side is equal to that side, I can therefore say that x will be equal to 3. Does everyone understand that part? Okay, so x is equal to 3. Right, let's look at the next one. 5 to the power of x is equal to 125. Now, let's keep that 1 over 125 in fraction form. I want to work towards getting a base of 5. Okay? But as soon as I think of 125, I know 125 is the same as 5 to the power of 3. No. Okay, so I'm going to start by saying that will be 1 over 5 to the power of 3. But my bases are not the same yet. No? Because on the left-hand side, I've got a base of 5, but on the right-hand side, it's still in a fraction. So I can't say my base is 5. But what I could do is take that to the top. What will then happen? That's going to become 5 to the power of minus 3. Do you guys remember this from when we did? Yeah? Oh, kyk nou, sorry, minus 3. Sorry. Dis hoekom jou gesig hier so lyk. Minus 3. When I take it to the top, or at least to the other side of the fraction, the sign of that exponent must change. Onthou julle dit? Nee. Okay, and now do you see base is 5 on each side? Nee. So I can only look at exponents. So then x will be equal to minus 3. Yeah.
And that is fine before you do 1 over 5 to about 3. It's fine if you first switch from one thing to the side.
Yeah. You can skip directly to this step if you want.
No, I mean, it's fine if you first do 125 to minus 1.
Minus 1, yeah. So he's asking, he wants to rather do this. So that will be 125 to the power of minus 1. And then I'm going to say 125 is 5 to the power of 3 and still to the power of minus 1. Or you could have skipped to saying that. No? And then x is minus 3. Okay. Any questions? Can I skip to the next page?
Yes, ma'am.
Okay, let's look at example 3. 10 to the power of x is equal to 0,001. Now, whenever we get a decimal, what do we have to do? Put it in a fraction form. Okay, so 10 to the power of x, and that 0,001 is what? 1 over 1,000. And that is the same as 10 to the power of minus 3. No. You guys understand? Because I skipped a step there. You fine with that? Okay. And now bases are the same. So I can say x will be minus 3. You guys fine with that? Okay. Now what about example 4? Over here, I have a few things added. So now we've got to think of our equations. Remember right in the beginning of the chapter, I made you write down those 4 steps. What was step number 4? Number 4 was exponent. So meaning I first got to do step 1, 2, 3, and then last, right at the end, I do my exponents. Okay, so step 1 was get rid of the brackets. But in this case, can I multiply this with this one? Because I don't know what that exponent is. I can't say 15 to the power of x, because that to the power of x does not apply to the 3. So I can't get rid of my brackets. Okay, then we go to step 2. Unknowns left, normal numbers right. Okay, so first things first, move over this minus 1. Right? Okay, so I am going to have 3 times 5 to the power of x is equal to 374 plus 1, so 375. Now I want to get rid of that 3. This is 3 times the bracket, so if I take it over, it becomes divided by 3. So 5 to the power of x will be that divided by 3 will give me 125. And now can you see on the right hand side, I can make my base 5. So 5 to the power 3. And because base is now the same, I can only look at exponents. So x will be 3. Does that make sense, people? So it just gets a bit more complicated. Still my equations, but right at the end, we sort out our exponents. Okay. I think there's one more example. Yes? Anyone still copying here? Okay. You done? All right. Example 5. Do you guys want to try that one on your own quickly? Yes, ma'am. Yeah. Probeer gou. Unknowns to the left, normal numbers to the right. After that, coefficient, and lastly, exponent. You guys done? Right, okay, so what would be my first step? Take the 9 over. Okay, so I'm going to have 2x to the power of 5 is equal to 73 minus the 9. So I'm going to have 2x to the power of 5 is equal to, okay, now I've got to get rid of that coefficient. So x to the power of 5 will be 64 divided by 2, but you could skip to just saying 32. Okay, and now I know in this case what my exponent is. How do I get rid of that to the power of 5? Fifth root. No. So x will be fifth root of 32. And that gives me how much? 2. So you said...
I just said 32
That's also fine.
shift manual.
It's fine. What she said is from here. X to the power of 5 is equal to, and then that's 32. She wrote an exponential form, and that was 2 to the power of 5. And then she saw the exponents are the same, so that means that the bases will then be the same. Okay. So either one of those. Right, now over here, almost the same principle, but I can't use her method now. How do I get rid of that to the power of a half? What's the opposite of square? Square root. What's the opposite of cube? Cube root. What's the opposite of to the power of a half? Half root. No. Okay, so I'm going to say x will then be half a root of 10,000. And you guys all know how to put that into your calculator? You can't use the normal square root sign. You've got to use the one, was I know? Yes, the one right above that in yellow. It shows you the root with a little block at the top open. And in that block, you fill in a fraction. So how much does it give you? No, not a lot.
It gives you a lot.
Yeah, okay.
Mine give me, yes, we do. I don't know what the other is.
What, Bolly? Okay, hold on. Sorry, ek het Wag, kyk gou. Sorry, maak daai vir my 100. Sorry, make that 100. That's it. Then my answer is 10,000. Sorry, ek het hom verkeerd geskryf, ja?
So you can't do a method where you first make the x to the power of half and negative x to the power of negative.
Okay, so does everyone understand? You guys good? Okay, so homework. Exercise 9.2. You only have to do number 1 and 2. At number 1, your exponent is the unknown. And then at number 2, your base is the unknown. Okay, that is it.